Welcome all. Today we will going to explore one of the most important challenge in deploying AI system, which is monitoring the deep learning models in production. Models are not static. They degrade over time due to drift in the data or environment. Our focus will be on the architecture for drift and matrix monitoring. So we'll understand here why monitoring is required, inputs for the monitoring, drift and the matrix monitoring systems, outputs and actions, all these things we'll understand one by one. So this is the architecture diagram, wherein in our data, our inputs will be coming from various domains. Like inputs will be coming from live model predictions, ground truth. Okay, it can be from external benchmark data sets, incoming data streams, historical data. All these things will be there. Okay, so firstly, we will understand why the monitoring is required. So here, there is one concept called as concept drift, which is a relationship between the input and the output changes over time. For example, credit card fraud pattern involved. Okay, like the pattern in the data before and after will change. Data drift, input data distribution challenges. Okay, likewise, new slang or spelling in the sentiment analysis is coming. So that is nothing but a data drift. Okay, then we will understand about the inputs like live model predictions. In the live model predictions, continuously flow from the deployed model will be there, continuously there. Then here we will have a real labeled arrived letters. Like for example, in our ground truth or a feedback validation, we will have a customer feedback, transaction validations, all these things. Likewise, in the external benchmark data set, we will have a gold standard reference to validate this model. Okay. So likewise, in incoming data streams, we will have a fresh data entering the systems. And in the historical training data, we will have a baseline inference for the drift comparison. Okay. So here, for example, think like a health checkup. Okay. Training a data is your baseline medical record and incoming data is your new symptoms. Okay. What is the new symptoms coming? Okay. And baseline medical record is your previous, whatever your previous record was. And now what the new symptoms are coming. This is nothing but your incoming data. And benchmark data sets are external, or we can say a second opinion on this particular. Okay. So here we will have a three types of drifts, drift and matrix monitoring system. So as we have understood why we need to calculate this drift, why we need to monitor this drift, we will understand there might be a concept drift detections. Okay, we can find out whether there is a drift or not. So if there is a concept drift is there. Okay, so if the input and the output relationship is shifted, okay, if the spam word involved causing models to miss detection, okay, causing to misclassification or misdetections. So here we can use multiple techniques like KS test, PSI test, KL divergence. All these tests are there for detecting this particular thing. Then there is data drift detection, which will compare the incoming data with the historical distribution. Then there is a data quality matrix, which will detect the anomalies in the data, like missing values, skewed features, outliers, all these things. Then there is model performance matrix, which will aggregate the drift and quality, which we can calculate by using matrix like accuracy, F1 score, AOC. Likewise, multiple things we can use here. Then after this, we will have the output. Once we have detected this with multiple techniques, we will have a performance matrix on what basis we are saying this and accuracy for this particular drifted. How much is drifted? So once we have understood that our model has been drifted, what we can do, we can have an automated alarms, okay, which will send the notifications when the drift or performance drop. Can escalate the incident management teams also after that. Okay, then there is a virtual dashboard which will a real-time monitoring interface which will help data scientists explain changes to the stakeholders. Then there is a model retraining pipeline, okay, which will automated retraining when the drift is detected, which will ensure the model adapts. Data quality reports which will provide the detailed root cause analysis between that, okay, which features the cause drift which data sources failed to explain. Okay, all these things we can just send it to escalate the issue to the incident management team. Okay, so this is how this monitoring and is required. Okay, continuously monitoring after training the model and after deploying the model, still the monitoring and maintenance part is required. Continuous monitoring is required. Okay, so let me show you one hands-on on this. Okay, so here let's take one data set from here. We have taken we are using here a scikit-learn library for the data set and pre-processing. You can see from the scikit-learn dot data set, we are importing load this breast cancer data set. So within this scikit-learn library, we are within this data sets, we are having this particular load, this particular data set. So we are loading this data set called as breast cancer. Then we are using this scikit-learn for splitting the data set. We are using it for scaling. All these things, accuracy score and F1 score, we are using for evaluation. Here we are importing TensorFlow framework, and we are from SciPy, we are importing strats. Okay, so this is what we are using here. So our first step is our helper function. Okay, so this is nothing but the helper function. This will do what? This compute KSP value will, which applies this KS test. Okay, there is one test called as KS test. Okay, this will check whether the two distributions are significantly different or not. The second one is a PIS test. This is nothing but a population stability index, PSI, which is a common matrix in model monitoring that helps us how stable or unstable our features distribution is from the baseline or a current data. A high PIS value means drift is there. Okay, so this is nothing but to identify, we are using this KS function and this PIS function for identification of whether the drift is there or not. Then we are loading our data set here. Once we are loading this data set, we are splitting the data set and we are applying this model. Okay, we are using this deep learning model here. This is our tf.keras. TF is nothing but TensorFlow.keras dot sequential. We are using our sequential layers, and all the layers will be in the ordered manner, ordered in a sequential manner. Okay, so first we are using inside, we are using this ReLU activation function, and for making the layers into one single layers of dense unit, we are using an activation function called as sigmoid activation function. Then as usual, we are using model.compile, wherein we will have our optimizers, loss functions and matrix. Then model.fit will have what? We will have the epochs, how many epochs we need to run this with the batch size of 32. Okay, so we are training our model into training data set and we'll evaluate on the validation data set. Okay, so once we will evaluate this, this will be your baseline model. Okay, so this is nothing but your baseline model. Now for data drift. Now for data drift part, we are again creating one drifted data. Okay, so we are creating one drifted data which will do what? We artificially introduce this drift into the test data. We have introduced this. This is not present. We are adding some drift in the testing data set. One feature is shifted by adding a constant value, and another feature is shifted randomly. Okay, so this will stimulate what? Two common scenarios, whether it is a distribution shift where the data slowly changes over time, and whether it is a feature corruption where the data gets messed up. This will give us a drifted data set to test the robustness of the model. Okay, how model is performing, and this will give us the drifted performance of this model. So we are purposefully adding in the testing data, we are purposely adding some drift in the data set. Okay, so now for a drift detection, again we are using this PIS and KS test, which will give us this detection of this particular, how much our data is drifted. So for performance of drifted data, we are again having F1 score, all these things. And after detecting this will produce what? Drift report it will generate, which will tell us which features have shifted the most. And whether the differences are strategically significant, the step is critical because it explains why the model's performance is dropping. Okay, so it will also give us a simple alerting alarm here. Okay, it will give us a simple alert. Okay, so alert in the sense, if F1 score drops by more than 0.1, okay, if F1 score drops by 0.1, what it will do? We'll raise an alarm. If PSI is more than 0.2, we flag a moderate drift. We will say that no, there is a moderate drift in a data set. Okay, if this KS test evaluation, if this KS scores shows a p-value below 0.01, so we also flag the drift. This is exactly what monitoring system generates automated alerts in the real world. Okay, in MLOps pipeline. Okay, so this is how it can also show us in visualizations. Okay, we pick the feature with the highest PSI and plot. Okay, plot it in a distributions. Baseline model versus your baseline model versus your drifted model. The visual comparison makes it obvious how the data has shifted, and it helps the data scientist communicate drift clearly to the business stakeholders as well. So this is like an alarm type of thing. So that once this alarm, for the alarm point of view, if the data shift, if the baseline model F1 score and the drift F1 score is more than 0.5, we will just give one alarm. If it is more than 0.2, it will say that there is a moderate drift over there. If it is less than 0, if the case p-value evolve is less than 0.01, we will say that no, your case just indicates that there is a distribution change. So there is a drifting happening. Okay. So here for the visualization purpose, we can see the visualization map over this feature. This is your baseline model versus your drifted model. So once I have run this, I have got all these information from here. You can see all these information from here, and it is giving me an alert. Okay, it is giving me an alert that PSI is greater than 0.2. Okay, so if it is 0.2, more than 0.2 detected on some features, there is a moderate drift. They are saying that this is a moderate drift. So there is a drift in the model. So you can see all this drift report is there. It has generated one drift report by using this some intermediate levels. It has taken some top 5 features by PSI. And based upon that, it is generated one report. Okay, so drifted accuracy is like this much, and this is your baseline model accuracy. Okay, and this is your actual baseline model versus the drifted model. Since in our test data set, we have purposefully added some drift in that data set. That is why here in this particular thing, we can see the drift is there. Okay. So what we have done means we have trained a simple deep learning model wherein we have established our baseline performance. Baseline performance means actual model's performance. And we simulated the drift and observed the performance drop within the data set. We applied some statistical techniques here like PSI and KS test to detect the drift. We raised the alert alarms and visualized the drift here. So all these things we have understood. Okay. So this is what our today's topic is. I hope it is understood. So if you need any inquiry regarding any courses, you can just call our salesperson or you can email us. Okay. Thank you for joining, guys. We'll meet you with the next topic in the new lecture. Thank you, guys.